be doing Physics 220, the Flux and EMF lab, where we're going to be examining the flux from a magnet passing through a coil. For the equipment for this lab, we have this tube. It's just a tube filled with some diluted water to make it a little bit thicker. And there's a bar magnet, with one end being the north, one end being the south. We don't know which one. In fact, that's what we're going to find out, which one's north and which one's south in the first part of the lab. But we can move this, flip it any way we want. Part of this apparatus is a coil in the middle, and from the coil, one important thing to note is that this black colored one is the ground, and then this is the positive terminal, and these wires are connected to a voltage meter, which is displaying on the computer here. The arrow drawn here on the top of the coil indicates the direction in which the wire is wrapped around the coil. So it's going to be clockwise when viewed from above in this orientation. When current flows in the direction of the arrow, one thing to note is that the voltage readout is going to be positive. So we're going to plug in the voltmeter here. The voltage readout is going to be positive if current is flowing clockwise from this perspective. Now, if current's flowing the other way, against the arrow, it's going to read as a negative voltage. So this is going to prove to be important information when we go ahead and do the experiment. But that's all of the equipment. For the first part of this lab, what we're going to want to do is determine which one of these, the blue end or the white end, is the north pole of the magnet. And so we're going to do this. I'm going to tilt this up like that, and the white end is going to go through first, and then the blue end is going to go through last through the coil. And so before we while we're doing this, we're going to record the voltage across these two leads, which is going to be help us determine, based on the flux and the right-hand rule, it's going to help us determine which one's the north and which one's the south pole. And so what I do before we get started my recommendation is, before we get started, think about what would happen if this white one were the north pole. Okay, we don't know if it is, but let's just say, okay, if the white one's the north pole and it goes through, there's going to be flux coming outward, right? And so in order to compensate this, the coil is going to need to produce a flux inward. So we have some conservation of flux, right? And so in order to get a flux this way, think about the right-hand rule, it would have to produce a current going around like this, right? And so if the current's going around like this, remember from the top of the coil, for current to flow from here to here, it has to go around clockwise from the top. But if this were the north pole, it would need to be going around counterclockwise. And so that would show up as a negative voltage, because instead of going from the negative to the positive, it's going from the positive to the negative, and so that's going to read as a negative EMF on our voltmeter. And so that's assuming the white one's north. I would do the same thing, assuming this blue one's north. Think through it in your mind, what would you expect to see? And then once we see the results, we should be able to decide, oh, this is the north one and this is the south one. So hopefully that helped. I know it's probably a little bit harder to do it in video than in person, but let's go ahead and collect the data. So I'm just hitting collect here and then turning it on its side. Okay, so the first thing that you're going to want to notice is that they're symmetric, right? Well, as symmetric as we can get. There's some constraints due to the data collection that it's not perfect, but we see it go up and then go down, and they're about the same size. It's just flipped, which is because we have conservation of magnetic field, right? All the magnetic field lines from this one go into here. And so here we have all the data that you need to figure out the pole. Because the white one, when it went through, it was positive, and then the blue one went through and it was negative. Okay, here's a zoomed in look at the data. The first thing that we're going to want to do is find the max EMF, the max voltage, either on the way up or on the way down, because they are symmetric. So I'm just going to do the way down because it has a little bit of a flatter a little bit of a flatter peak there. And so I place the cursor over there. The cursor is telling me that it's at magnitude doesn't matter. We just care about the absolute magnitude. So, the sign doesn't matter because we just care about the absolute magnitude. So we're at 0.0548 volts, or 54.8 millivolts is the EMF when one of the poles is midway through the coil, the max EMF there. And then what we're also going to do is we're going to take an integral. I'll just go ahead and use the top one for this one, but I'm just going to select over, equal side distance on both sides of the peak, and we're going to have the computer integrate under the peak, and that's the integral there. And so using the equations on your sheet, you can then compute the flux by taking that integral, and from there you can then divide by or take into account the area for the magnetic field, and that will give you the actual magnetic field strength if we take into the area of the coil and assume it's uniformly distributed. So that's all the data that you need, and good luck with those final calculations.